All right, let's just jump right in. For the better part of a century, we thought we had a pretty solid grip on how the universe worked. We had this grand story, a theory that explained almost everything we could see. But things have gotten weird. Lately, evidence has been popping up, glitches in the cosmic code, things that just don't fit. And these aren't small details. They're like finding huge cracks in the foundation of reality itself. And look, this isn't just some crazy talk from the fringes of science. It's a genuinely terrifying thought that more and more top cosmologists are being forced to consider. The data we're getting back from our most powerful telescopes, well, it's telling us a story that just completely contradicts the one we've been telling ourselves for decades. That theory has a name. It's called the Standard Model of Cosmology. And honestly, it's been a rock star. It's predicted everything from the faint afterglow of the Big Bang to the way galaxies clump together. But it's starting to break. So today, we're going to play detective and look at 4 key clues that tell us we might be on the very edge of a new scientific revolution. Okay, our first clue in this cosmic mystery is a major disagreement about maybe the single most important number in all of cosmology. It's a problem they call the Hubble tension, and to put it bluntly, it's a total disaster for physics. Think of the Hubble constant as the master dial for the entire universe. If you know this one number, you can figure out the universe's age, what it's made of, and even its ultimate fate. So for years, nailing down this number has been the holy grail. The problem? We've now measured it with incredible precision in 2 totally different ways, and we got 2 totally different answers. So how in the world do you measure the expansion of everything? Well, the first method is to look way back in time. We can actually see the baby picture of the universe, this faint glow left over from the Big Bang. It's called the cosmic microwave background. And based on that ancient light, our standard model predicts exactly how fast the universe should be expanding today. The second method measures the expansion right now, in the adult universe, by using certain stars and exploding supernovae as a kind of cosmic tape measure to see how fast galaxies are flying away from us. And here is the crisis. The baby picture method predicts an expansion speed of about 67. The cosmic tape measure method gives us a speed of about 73. And just look at this chart. The scientists are so confident in both of these numbers that their error bars don't even overlap. That's not supposed to happen. The odds of this just being a random mistake are less than 1 in a million. So if both measurements are right, the theory that connects the beginning of the universe to today must be wrong. So what does this mean? It means something must have happened between the dawn of time and today that we have no idea about. And the possible explanations sound like they're straight out of science fiction. Maybe there was a burst of early dark energy that gave the universe an extra push and then just vanished. Or maybe we just happen to live in a giant, unusually empty bubble of space. Or, and this is the one that's really unsettling, maybe the fundamental laws of physics aren't as constant as we thought they were. All right, let's move on to our second clue. This one comes to us from the incredible James Webb Space Telescope. It was built to look back into the cosmic dawn to see the very first baby galaxies forming. We expected to find a cosmic nursery full of toddlers, but instead we found fully grown adults. See, our models were crystal clear. In the first few 100 million years after the Big Bang, galaxies should have been tiny, chaotic, messy little blobs of gas. But when JWST looked, it found huge, well-organized, mature galaxies. Galaxies that look a lot like our own Milky Way, existing just 500 million years after the Big Bang. That should be completely impossible. It should take billions of years for a galaxy to get that big. Astronomers actually have a nickname for these things, universe breakers. And that's because they do exactly that. They break our understanding of the universe. To get this massive, this quickly, a galaxy would have had to turn basically 100% of all its gas into stars with an efficiency that just doesn't exist. It's like finding a fully built skyscraper and being told it went up in this single afternoon. This whole paradox has sent absolute shockwaves through the astronomy world, because if these observations are right, and every indication says they are, then our entire theory of how structures form in the universe is deeply and fundamentally wrong. The explanations being kicked around now are just, they're mind-bending. Maybe the Big Bang wasn't really the beginning. Maybe the universe is way older than our calculations say. Or maybe, just maybe, the seeds of these giant galaxies weren't gas clouds at all, but primordial black holes, actual monsters born in the first second of creation that acted like giant gravitational anchors, pulling everything together at insane speeds. Our third clue is a bit different. It didn't come from billions of light years away. It came from right here in our own cosmic backyard. Back in 2017, something from interstellar space came for a visit, and it behaved like absolutely nothing we had ever seen before. We called it Oumuamua. That's a Hawaiian name that means scout. It came screaming through our solar system at an incredible speed. It was the first time we'd ever confirmed that an object from another star system had entered ours. But the path it took was bizarre. As it swung around the sun and headed back out, it sped up. Now, comets speed up all the time, no big deal, right? As they get close to the sun, the ice on them heats up and vaporizes, shooting out gas and dust that creates a tail. This outgassing acts like a tiny rocket engine, giving the comet a little push. But here's the thing. When we aimed our best telescopes at Oumuamua, there was nothing. No gas, no dust, no tail. Zero. And yet, it accelerated away from the sun as if it had an engine. It was being pushed by some kind of phantom force. This led Dr. A.V. Loeb, who was the chair of Harvard's astronomy department at the time, to a pretty wild and controversial conclusion. He argued that the only force we know of that could push it without any visible exhaust is the pressure from sunlight itself. But for that to work, the object would have to be incredibly thin and light. We're talking less than a millimeter thick. And nature just doesn't make things like that. But you know who does? Engineers. He proposed that the simplest explanation is that it's an artificial object, maybe a piece of a light sail, a kind of spacecraft designed to be pushed by starlight. So all of these clues are troubling, but honestly, they all pale in comparison to our final anomaly. This isn't just a crack in our understanding, it's a canyon. It's often called, and this is not an exaggeration, the single worst prediction in the entire history of science. So, according to quantum mechanics, our best theory of the tiny subatomic world, empty space isn't actually empty. Not at all. It's a roiling, bubbling soup of virtual particles that are constantly flashing into and out of existence. All of this activity creates a huge amount of energy, and we call it vacuum energy. Okay, so here's the deal. Since energy has gravity, we can actually measure the effect of this vacuum energy by looking at how the universe expands. So scientists did two simple things. First, they used quantum theory to predict how much vacuum energy there should be. Second, they used astronomy to measure how much there actually is. The prediction was wrong. And it wasn't just a little bit wrong, it was wrong by a factor of 1 followed by 120 zeros. I mean, that number is so big, it's basically meaningless. There are more zeros in that error than there are atoms in the entire known universe. If the theory were right, the energy in every cubic centimeter of empty space would be so powerful it would have instantly ripped our universe to shreds the moment it was born. This right here, this is the heart of the problem. This mismatch, which they call the vacuum catastrophe, tells us that our two pillar theories of reality, quantum mechanics, which describes the small, and general relativity, which describes the big, are fundamentally incompatible. They just don't work together. Something about how we understand space, time, and energy is profoundly, catastrophically wrong. So, a universe expanding at two different speeds, galaxies that are too old for their time, an interstellar visitor that moved without an engine, and an energy calculation that fails on a cosmic scale. Where does all of this leave us? You know, this isn't really a story of failure. It's a story of discovery. Every huge leap forward in physics has been kicked off by anomalies just like these, cracks in the old ideas that make room for something new. These clues are like signposts, pointing us toward a reality that's deeper and, frankly, way weirder than we ever imagined. Our standard model isn't wrong, it's just incomplete. These anomalies force us to question literally everything we thought we knew. They represent the absolute edge of human knowledge, that border between what's in our textbooks and the vast, unknown cosmos that's still out there. And it leaves us with one really profound question to think about. Are we watching the trusted laws of physics completely fall apart? Or are these clues the very key that will finally let us read the true rules of reality for the very first time?